Now, ladies and gentlemen, of course, we'd like to get into the gist of today's agenda. We'd like to first and foremost thank today's sponsors, NS BlueScope, Lyset Sdn Berhad, for their support of the event. And at this point, we'd like to invite our sponsor representative to have his introduction of the product, Ms. Wendy Eng, who's a Technical Solution Manager, to please come on to the stage to give her talk and her presentation. Thank you.
Hello, can you hear me? Sorry, I'm a bit short. Okay, good morning. Yeah, so my name is Wendy Eng. I'm the Technical Solution Manager from NS BlueScope Lyset. Yeah, so I will start with some product briefing. Sorry, it's not this slide, it's another slide. It's another pack. Yeah. Okay, so who we are? So anyone heard about NS BlueScope Lyset? So who is actually NS BlueScope Lyset? So why we are today here? Okay, so we are actually a steel making company. So we start from iron ore. So everyone can see from the flow that this is how the steel making from. We from our raw mat iron ore limestone. Then it actually go through a production. Then it become a hot roll. Then it become a cold roll. Then it's become to the end user product. It can be a rebar. It can be a hollow section. It can be a plate. Okay, so this is NS BlueScope business. Okay, so in NS BlueScope business, we have our value chain here. We have our upstream, midstream, and downstream. So how we so-called upstream, midstream, and downstream. So people always confuse like BlueScope and BlueScope Lyset. So upstream is actually from our Australia, where they produce the steel from the raw material, like the iron ore, that's all. So from midstream, then where they produce the coil is in hot roll form. Then they will send the hot roll form to midstream. So midstream will actually further process it to a cold roll, and from there we're actually going to coat. Means we're going to have a coating on the roll. So the coating is actually to prolong the steel lifespan, and also from the cold roll we will actually send it to a downstream, which is the Lyset business, and we will actually provide it and send it to the market to the end user. Okay, so this is our so-called BlueScope value chain. Yeah, so now I'm actually NS BlueScope Lyset. We are actually in the downstream business. We are the one who actually give you the roofing solution. Okay, so highlight a bit. NS BlueScope is actually listed in Australia since year 2002. So we have our business cover 18 countries. So you can see from the map here. Yeah, and we actually have a 14,000 employee up to date. Okay. So NS BlueScope is actually also joint venture with Nippon Steel in year 2012. Okay. So the whole Asian market like Thailand, Vietnam, Singapore, Malaysia, we actually joint venture with Nippon Steel. So after that, from BlueScope Steel Malaysia, we actually convert ourselves to NS BlueScope Steel Malaysia. So it's actually NS stand from Nippon Steel. Okay, so this is our plant in Kappa. So the first Kappa plant is actually started in Malaysia since year 1996 as coin painting line. Then further 1997, we actually have our coating line. So right before MCO, right before COVID, we actually acquisition another plant in Sungai Buloh, Klang, Kappa in year 2018, where this is the plant they're going to produce hot roll to cold roll. So right before that, we are actually all-time import cold roll, but yet in today, we actually do our own cold roll. So we just import hot roll. So yeah, so this Malaysia plant is actually we serve the cluster from Malaysia and Singapore. Excuse me. Okay. So NS BlueScope, we actually carry the brand of Colorbond, Zincalam, TrueCore, Wormore, Prima. And yet this is Lyset plant in section 16. So we have our Lyset plant, and also we actually have our operation in Shah Alam, Kuching, and Kota Kinabalu. So the rest, we have our sales office and operation office in Penang, and in Singapore, and also in Johor Bahru. Okay, so yeah, we started in Malaysia since year 1968. We are the first roll former in Malaysia since right before anyone. So yet, this is our journey of NS BlueScope. So in year 2000, we are the one who actually bring in the steel truss to the market right before there's all-time timber truss. Yeah, and for longer and longer, actually in year 2010, we start to promote our SIM profile. And yet, we actually celebrate our 15 years anniversary in year 2015. Yeah, so soon we're going to have our 60 years. Yeah, so what solution that we have to support your project needs? So when it comes to steel, I think I need to lower down. So thank you. Or maybe I can raise this thing up. Okay, much easier. So what's concern of using steel today? So we always have a concern that steel is very industrial look and actually cannot form uncomplex or actually unusual, irregular shape. Okay, so and actually very easy to rust and corrode. So this is always that people come back to us and tell us what's the problem that they don't like steel. So it's very noisy and it's not thermal conductive. Yet, but today I'm going to share with you how that we actually counter all these things and how steel actually can be so perfect and actually go through or gone all these things. So to be fast, actually NS Brusco, we actually have few profile here. So we actually offer conceal fix. We also offer pierce fix. So confused fix is actually a metal deck that's going to be installed on your roof and you don't see any screw. So what is the benefit of not having screw is actually you don't have any leaking. Actually reduce the leaking possible and also reduce the leaking risk, and also because of conceal fix you don't have any worries about the thermal expansion things for your roof. And also pure fix is the conventional type that we normally use it for wall cladding, and also in NS Brusco we also offer our decking system. I'm not going detail one by one because I think once you walk out from this room you will definitely forget. So, but I will go in very quick, but if anything that you come to design, you face anything that you always feel free to talk to our team. So our team is actually outside the door. Okay, so we have our click lock profile. So the beauty of this click lock profile is actually it has a very high rip, so it can cater very, very low pitch roof at 2 degrees. Okay, so it's actually a click system. So what is good about click system? Because when you have ever have click, there's no screw going to penetrate to your roof. Because when it comes to Malaysia weather, right, when sometimes thermal expansion, when the metal deck move, right, then the screw hole will become bigger and bigger. So that's where the water leak. Okay, so if let's say you have click, no screw, then you actually have all these problems solved. Yeah, then after that we have our 360 seam. So the beauty of this 360 seam is actually it can form any shape. It can go taper, it can go dome, it can go round shape, whatever shape that you think of about aesthetic. Standing seam is the one who can do this job. Okay, and yet also we have our zip deck. It's a very bold seam profile, and this profile is actually can go 1 degree. The beauty of this profile, because it's very huge, it's very big. So then we have our edge. So this edge is actually one of the alternative for composite panel, and the beauty of this edge is actually where we install without any silicone. Because wherever you have silicone, where the time when silicone start to deteriorate, right, then you start to see all the black stain on your building. So yet this is only we need to apply screw on the ridge, then we actually fold it. Then yet also the spandex Optima, we normally apply this for our wall cladding, and this is the profile that we actually comply to BSA 414. Yeah, about for the fire that all the building above 80 meters, there's a new regulations that you must meet BSA 414. And also we have our trim deck. That's the most economic profile that we have to cater your needs. And also we have HR29 Optima. So this is the special profile required by IKEA. They want to have a very bold high ribs. Yeah, just for aesthetic purpose. Yeah, then we also have our multi-clad that's suitable for the wall cladding. So this is because of the rib height is very low, 12 meters. So we only apply this for wall cladding, not for roof. Okay, then also we have our bond deck. So we actually supply this bond deck to our KLCC tower. And also we have our smart deck. Okay, so this is more engineering design. Yeah, so what's the advantage of using metal cladding? It's actually a building envelope for your building. And actually, whistling appearance, it can come in any types of color. So as long that if, let's say, color bond have white, you want blue, you want green, you want red, we come in any color as your like, as your choice for your design purpose. And of course, it's actually more lightweight compared with the others material, and of course, not combustible. Okay, so comes to construction efficiency, it actually can be installed very fast compared with the others, and also environment friendly because the material are 100% recycled. So yes, durability and long term. So there's the data saying metal roof is actually can last more than 100 years. So in long term wise, it's actually save your cost because there's no maintenance needed for your roof, and actually there's no repairing or anything required for your roof. Yeah, and also just now when I shared that we have our 360 SIP, it's actually very design flexibility that you actually can form any shapes that you require, like tapered, curved, dome, whatever shapes that you are looking for. Yeah, so right material is actually create impressive and long-lasting building. This is very important because if I choose metal deck, but I want my metal deck to be last long, but not every metal deck in the market are actually the same. So yes, is all the coated steel the same? No, I can say no. Yeah. So yes, at NS BlueScope, we actually offer Colorbond, Zincalume, Vermo, and TrueCore. This is the 4 key brands that we actually carry for our project segment. Yeah, so NS BlueScope, we are actually accredited to ISO 9001 and also 14001, which is our environment ISO. And also all our material are actually comply and meet CIDB at 520 and PPS, which is Sijil Perakunan Permatahan Standard. So, and all our products are also recognized for green attribute like CRIM label certificate and also Singapore Green Building products. Okay, so this is our product. So we have our bare finish, which is called Zincalume. Then of course, comes to Colorbond, we have few series of Colorbond to serve your needs. We have the matte surface, we have the metallic surface, and of course we have a higher coating to serve marine environment or very corrosive environment. Then we have Vermo to actually have the texture finishing. And of course, TrueCore is actually for truss. So this is some of the example of building in different finishing. Yeah, so the difference is for NS BlueScope, we also offer AZ150, which is 55% aluminium, 43.5% zinc, and 1.5% silicon. So that's the difference that while compare ourselves to the market zinc, which is only 100% zinc. So you can see from the picture here, that's the comparison after 30 years from Zincalume with the others generic material. Then you can see also that others materials start to have a darkening surface, where actually Zincalume still looks exactly new. And there's some comparison of 20 years comparison. Yeah, so when it comes to coating, comes to color. So this is the superior corrosive resistance. We actually pass under 500 hours soft spray test. And not only that, also we actually put our metal deck into a normal actual environment. So you can see from this color fading change at the item 2 here. So actually color change, I mean, I can say so in market there's nothing forever. Yeah, so same goes to color, it will not be forever. So it's just like how it fade, how is the delta E value change? Because color we measure by delta E value. So you can see from the above chart here that you can see that for Colorbond to the actual sample that we supply is only at 4.2 delta, where the others material is already up to 20 over delta. So it's actually, you can see there's a lot of blue building, then end today it become a zinc building. This is because the colors start to fade. Yeah, and also with NS BlueScope, with our Colorbond, we also actually offer dead stain warranty, which is the clean technology. So the water, the rainwater will actually auto wash off the dirt. So you can see from the dirt stain resistant at number 4, that you can see the difference. Yeah, and also peeling is very important. Yeah, so actually why Lysat? Because we don't want your roof to be failed. I don't want your iconic building to become something like, and today you need more people or more manpower labor to repair it. So this is some of the example. You can see, especially now climate change, there's more and more place, the weather change, keep raining, flood. So this is the risk of coming. So this just happened last year. Yeah, so what is actually wind uplift? So wind uplift is actually your internal building wind greater than the outer. So it becomes wind uplift. But yet I can say wind uplift can be good things also for the guy. Yeah. So yet all our NS BlueScope material, we actually pass through this AS4040.2, which is the Australian standard. So we actually comply ourselves to another lab test. So all our wind uplift tests, we actually go through a certain procedure for the testing. First, of course, we need to, according to AS4040, and also the serviceability, the strength, the load, and also apply to safety factor to sustainability and strength load according to AS standard, and then we will determine the wind uplift capacity. So all our NS BlueScope Lysat product, So all our NS Bruce Code license actually go through this wing lift test. This is some of the example tests that I'm going to show you later. Yeah, so this is how the test going to works. Yeah, so we will install our clip lock on this machine. Then there's a wing going to blow under this metal deck. Yeah, so because normally wing uplift, the greater wind is coming from the underneath of the building, inside the building. Yeah, so the test will actually stop when after the metal deck got broke. Yeah, then the test will actually stop. So from the test, we actually came out all this table. The limit state wind pressure. So according to this, I mean all this table actually published in our website and also printed in our brochure. So based on comes to calculation and comes to design, right, then this table is a very good reference. Yeah, so others that wind uplift, NS Bruce Code product also that NATA actually help us, others that wind uplift, the NATA lab test also help us to do point load test because upcoming sustainability, everyone's going to install solar panel on top of your roof. So we also have to cater a load set where the solar guys go up to your roof and do maintenance and also the cladding installation test. So yeah, so those things are actually very important to take into consideration. Yeah, so this is actually our test report and everything was being stated in the test report. And it's also printed in our brochure actually. Yeah, so this is some of the table sample wind uplift performance table. And yet, okay, so NS Bruce Code license, we also tested and certified under CRIM. And our product are actually compliant to BS 476, Part 6 and Part 7, Class O. This is more on fire. And we also comply to CIDB Act PPS. And also our trust system are actually recognized and approved by JKL system provider. Yeah, so what do we offer in LISAT? So in LISAT, we actually offer BIM. We do have our BIM ready if you require to. And also we actually offer our detailing drawing. It's let's say like if you want to know how is the end lap, how is the flashing going to be designed, what is the lappings looks like, how is the capping, everything. So we actually provide all the detailing and of course we all provide the system as well. And how you want to do the termination for your system, and so on. So yet we also provide our gutter and rainwater dowback calculation. You will actually have this in our website. You can just key in your data, then you will actually automatically generate that what is the gutter size that actually you need. And yet you also have some tools that how to do a spec, how to select a spec, what type of system that you require. So like example, like if let's say I need a STC, sound transmission class for my project, yet this system is actually able to help you to build up the system. Yeah, and we also have our visualization tool that we actually launched this last year, sorry. So this visualization tool is like something that where you have your own building, then you want to imagine how the buildings looks like in red color example. So you can use this tool to actually apply the red into your building. So it will give you some visualizations that how your buildings will look like in red. Okay. So this is a sample. So also, and we actually provide, I mean, like others that if you feel that you don't want to go through the system, you feel that you don't know how to key in the numbers, or you feel that you're too busy to do that. So yeah, we are actually, you can talk to our salesperson. We will actually advise you, we will give you the calculation according to your requirement. So we actually can provide you the U value calculation and also the STC calculation. So for the STC, we are actually using our INSU software. Yeah, so this is the example of calculation that we provide through our architect. So we are actually based on UBBL clause 38A. So for our lightweight, we actually, method that is under lightweight, so we are consider ourselves 0.4. Yeah, so just now I am being cover everything. So we have a lot of profile. We have our profile to actually come out a very distinctive design that you required. Dome size, curve size, whatever size. And also comes to acoustic and thermal insulation, of course, it came with system. We will provide you the system according to your request. So the good about metal deck is like for the system, right? For good acoustic, so far in Malaysia, we have experience to build up to a STC 60. Yeah. Then also we have our water tightness and leak-proof profile. Yeah. And also flexible and can redesign and actually looks very new and zero maintenance. Yeah, so there are some selection criteria that really need to take concern when it comes to material selection. So of course, material performance, corrosive resistance, make sure that your building don't corrode after few years. Yeah, because you might want to build your iconic project, but you don't want when you pass by, then the building start to corrode. And also excellent color, long-lasting color. Just like you make sure where you design in blue, that's forever in blue. Then after that, we have our superior premium technology. Make sure that your paint not peel. And also thermaltech technology, that's more on green to reduce your indoor temperature. And also the clean technology, that's zero maintenance, where the rainwater can auto wash off the dirt of your roof. And also all our material that's sent to site will actually have a branding text at the back of the material. Yeah, so called something like a bird cert. So touch wood, if there anything happen on the material, we are able to trace that which batch or which production or which date we actually produce this coin. Yeah, so it comes to others that comes to the material selection, the profile selection, the reliability of the end product is also very important because we don't want our roof to fly off, so wind uplift. And also foot traffic, because there's only always have people going to walk on top the roof if let's say you have a solar panel. And of course the rainwater drainage capability, because you don't want your gutter to be overflow and goes into the building. And also the flexibility of the material when it comes to site installation. And also well protected for water ingress. And also the system integration ability. Yeah, so our roof are all actually solar ready roof. I will share more this in later. Yeah, so also you have to consider about your sound transcription, your STC requirement, and also your U value. Yeah, so this is some of the selection criteria that have been actually listed here. So the location of the building is also very important because where the location is very corrosive environment or very near to the marine, we probably need some special material, some higher thicker coating material to serve that environment. Yeah, so comes to building application are the same. Just like example, if you are a glove factory or you are a swimming pool hall, so that's actually special others made of material, not on the standard material can be applied. Yeah, so this is some of the case study that I always bring up. So this is actually a Labuan jetty. We actually taken the first photo in year 2004. Then after that, we went back again after 10 years on 2014. So you can see everything are still nice, even that actually next to the marine. We are actually expected it going to be corrode, but yet after, I think last 2022, we went back again and everything is like actually looks so nice and there's nothing changed. But yet there are still, we actually spot some corrosion under the purlin, the unwashed area, because when the salts go into the building under the purlin, so the rainwater cannot reach the area. So we actually spot some corrosion on the unwashed area. But actually the whole entire surface, the building actually still looks good. Yeah. Yeah, then this is also one of the private house, the bungalow in Bintulu, that we actually went back after 20 years. So you can see the building is actually still look nice and the neighbor house actually start to corrode. Yeah, you can see the different, the red roof and the white roof. Yeah, so actually, very often we actually went back for case study so that we want to make sure that actually our product actually perform. Yeah, so this is the one that I always like to take this as an example. There's a high-rise hotel next to this development. So this development is actually started its spec color bond, but unfortunately they awarded to two different team of contractor. So the contractor A, yeah, she actually followed everything according to the spec. So you can see everything still look nice, still looks in green. But the contractor B is actually came in value engineering, counter purpose. So you can see that that's the difference between Briscoe material and non-Briscoe material. I think I went back this project site again last year. So some already painted in green, some already painted in red, and some even changed the roof. Yeah, so now I can see the center part is in colorful shape. Yeah. So yes, try to avoid all those when it comes to selection criteria is very important because you don't want in future that it needs a lot of replacement or maintenance to your roof. Yeah. So how to specify license? We have our team outside there. We always feel free to engage with our team. We will always happy to give you the right up spec. Yeah. So this is some of our project reference. We have our CJ Bio. So this one is actually we supply in clip lock Optima, and the wall is in trim deck. Then we also have our Chow Bay, the Batu Kawan. Wherever you travel to island, you will actually see this building. And also we have our Hassan Business Park. This is the business park that the owner says that they don't want to have metal clad on the wall cladding. They don't want to have so industrial look. They want something in special. So we have our S-Watch on the wall cladding. Then we have our Starbucks in Simpang Empat. And this project actually award PAM competition. Yeah, then we also have our residential. So more and more residential also opt for metal cladding. Yeah, then we have our Hans Academics. This is in Malacca. And so far, we only 360 sim can actually do this job. Yeah. And this is actually in metallic SPD person, copper penny. And yet also we have our hospital, UiTM Puncak Alam Hospital. And also we also supply our bomb tank and our span deck to Petronas Twin Tower, Merdeka 118 Tower, and also the TRX. Yeah, that's all from my product presentation.
Just leave it there. Okay, thank you once again, Miss Wendy Eng. You can give a round of applause if you like, no issue. I never thought I'd see a picture of Marilyn Monroe during that uplift on the wind thing. It's an interesting insertion. And now, ladies and gentlemen, to begin our first session, I'd like to call upon architect Michael Ching to please come on stage for his presentation. Is architect Michael Ching in the house? As you can see, he's very casually dressed today. Okay. Ah, okay, that explains it. It's okay, it's a little bit informal here today. So I've been told that Mr. Architect Michael Ching will start first, and then I will re-invite Miss Wendy Eng to come back on the stage after the coffee break, okay? Yes. I mean, I admire your choice of clothes for today. Okay. So yeah, let's get the presentation ready, and thank you so much.
Hi, I am Michael Ching. That's not my brother. Okay, I will actually take more than 1 hour. So if you guys hungry, in between, they can keluar, right? Makan, right? So okay, let's start. Tak boleh. Mana? Point there, right? Which button? The middle one, right? Need to manually board. Okay, 7 parts. I will go very, very fast. A lot to cover. 145 slides. Cannot finish in 1 hour, confirm. So there are 7 parts. First introduction. Humbly says that I do not know a lot of people here. Sorry, I seldom come back to PAM. So I assume that a lot of people do know me. So I'll do some introduction of my company and myself. We have a group of company called Be Green Riverstone Elite, where it separates into 2 companies. The first one is the Be Green Associates, which is on your left, predominantly doing all the operation carbon. Your group building stuff operation, reduce your energy, reduce your water and all this stuff But the river stone environment is more on the embodied carbon, which is more on calculating your embodied carbon, your ESG, your scope 1, scope 2, scope 3, which is getting momentum. The last 15 years mostly on green building, but the embodied energy is getting momentum, and we are talking about total carbon solution. So both companies can do that. Of course, the green building side is supported by CHNI Architect, which is I'm heading the company. The architecture side and the MAE is headed by BST, all under one roof. It's not a loose collaboration. Today, JV thing is all under one roof. Supported by the three on the bottom. These are different companies, but all support. The company has been in the market for 15 years. Personally, this is my portfolio. I was in PAM Council many years ago. I was in PAM GBI quick a few years ago. Still in MGBC. I have Green Mark accreditation. My crest, one of the first batch of the 30 under 40 many years ago. Won some award. Those are the awards. The last few years, our projects, some of them are CHNI, our companies. Some of them are other companies where we help to turn green. Won numerous award. There was in 2022, we won the best green building in Malaysia. Very important. This award was, you don't need to buy a table to get an award. They actually give money to the best green building. So we won the best green building in Malaysia, in ASEAN in 2022. 2023, we won in ASEAN and Malaysia. 2024, which is next week is the dinner. We won the best green building in Malaysia, ASEAN, and Asia. So we are getting to Asia. We beat Japanese and Koreans in green building. So we are in par. So that's a quick introduction of myself and my company. Sustainable design. Why do we need sustainable design? UPPL 38A. You know UPPL, or you're all architects. In 38A, it actually mentions that new or renovated non-residential building with air conditioner space exceeding 1,000 meters square shall be meets OTTV. Requirement meets the MS 1525. So refer back to 1525 to meet the OTTV. I presume all know OTTV lah, and roof U value RTTV, and of course provide EMS if required for air conditioning more than 1,000. So if it's not required, and of course required roof for all building, very important. Roof U value is for all building, residential, non-residential, to meet the roof value of 0.4 or 0.6 respectively for heavyweight and lightweight. In the latest UPBL, it actually mentions no more 50 kg per meter cube, no more. It's more on non-concrete roof or concrete roof has been amended. A lot of people say that, well, this is the UPBL, it does not cover residential. This UPBL is gazetted BSO 2017. In 2017, MS 2860 gazetted, and that includes the all new existing residential building. The UPBL is gazetted before, that's why it's not there. But most of the authority now in UPBL, in DPKL and PJ, I'm sure you all kena lah. All your new project, residential also, they say, yeah, calculate OTTV because of this 2880, 2860, not because of the Gazette 15.5. Okay. Go back one slide. Can you go back one slide? Okay. The next segment is very important. We know this is a law. We know this is gazetted. We need to do. Traffic light rate, we also no need to stop lah. But some people jalan also, right? Same thing. We know this is we need to do. But they are green consultant. Green consultant, no need to do anything. You ask the green consultant do, and we'll just sign lah. Partially correct lah. I think as an architect, we are the SO. We are the overall person in charge of the building. I think we should know something. When the engineer design a 600 by 300 for a terrace house car porch, we know something wrong lah. When the engineers design a 2 horsepower for a small room, we know something wrong lah. when a green consultant tell you to turn to low E glass, which is the easiest way to do, somehow we know that it's not totally correct. There are many, many ways. I think this is why I'm here today, to share some of the works that we have done. There are many ways to do, and we as an architect should know. And of course, the detail we can leave it to the green consultant, but we should know when there is a red button, there's a red light, and we know that this is not correct. So that is about today. And next, these slides I just inserted yesterday. Yesterday before I sleep, I was checking my social media, and I saw this. This is interesting. They said the fastest thing on earth, cheetah, then airplane, then speed of light, then people become specialists in sustainability. True, everybody claim that they actually they know about green, but a lot of them actually are very surface. We have seen sustainable report by a lot of big companies that the figures are not right. Okay, I don't want to get into trouble by naming them, so let's continue. So okay, let's start OTTV. Very fast, if you need to stop me, please throw something down. Okay, all the projects that I show is actually our company project, CH&I Architect company project, except that it actually mentions that it's not ours. So I put a note that it's not ours. So whatever we show is ours, so we got a client consent to show, so don't worry. 10 Stoner, OTTV, at the end, this is a CBA project, which means completed project, is 44. Benchmark is 50. So we are 10% lower okay? So, okay, good, great. So this is the building in KLCC. It's an interlock building. It's an L-shaped building where the full glass is facing the Selangor Royal Club or KLCC. It makes sense, but it's also facing the south and the west where a lot of heat. So no choice, because those are the best view and those are the market price are easier to sell. And it's a single loaded building. I will not need to explain all architects here. A single loaded building, so the corridors are facing the north and the west, which is on the, you can see the corridor there, so you can see the unit there. Okay, next, so this is in general, you can see the north point there, so you know it's facing south and it's facing west, facing KLCC. Real picture, can see KLCC, but unfortunately only 30 story and above. Okay, the building, one of the finalists in PAM competition for that year. Kuala, didn't win, very angry. Oh no, joking. Okay, in life you win and you lose. Okay, OTTV, this is the formula, but don't worry, the formula is created by many years ago, group of engineers, scientists, or without architects. So they create this formula to scare architects. So don't be scared. Nothing difficult. All this jargon, it can only be grouped into 3 parts: heat conduction through wall, heat conduction through windows, and solar heat gains through window. You need to know what is conduction. Conduction teach in Form 1, right? So you guys should know. Conduction, very important, because basic concept. All these somehow, don't know why not teach in GBI, but I'll try to go through here. Conduction means when you touch something, if the steel is conduction, the steel roof just now, Wendy mentioned conduction, and one end very hot, somehow the heat will come to you in some time. Conduction, it conducts. So the conduction through walls. So if the heat is from outside, it heat up the wall, and you touch inside, sooner or later you'll feel the warmth because it conducts inside. Conduction, Form 1 math, Form 1. Conduction through window, same. Touch, somehow, the heat kena hard. Solar heat gain, radiation. Radiation, you go out the sun, no conduction, didn't touch anything, touch the air, right? But hot, right? Radiation. Okay? So radiation and conduction. Conduction, you need to touch, heat touch. Radiation, no need. Go out from sun. Okay? Very important. So these are the 3 things that you need to know. Conduction to wall, conduction to window, and radiation. Tiga. So the lower the OTTV, the better. 50, the Stoner project, we got 44, right? The lower the better. 30 better, 28 better. Simple lah. Just like your blood pressure lah, lower better lah. Okay, your sugar level better. Your fees is the ballet. Okay. Fees the ballet. Okay. From there, I'll break down to 1, 2, 3, 4, 5, 6 things that you need to know. No need to take photo lah, don't worry. Don't worry. Whatever mau bagi saja. Don't worry. Nothing that you do not know. Really, nothing that you do not know. It's just that I'm here to share so that to remind you only. You know all these things lah. Okay. 1, 2, 3, 4, 5, 6. One by one, I'll go through one by one. Orientation, tao lah. Okay, you need to face north and south. Don't face east and west. Tao lah. But this thing you may not know. Okay. Everything in balik. Everything is in formula, right? Formula 15 alpha. What. Now we're talking about OF. OF is orientation factor. We mentioned that anything lower better, right? Per pressure. Everything lower better, right? So we are looking at 0 point something better lah. Correct or not? If it's 1 point something, no good lah. Correct? 1 point something means more heat. 1.2 heat more. Correct or not? 1.5 heat more lah. 0.5 heat lesser lah. Okay, everybody knows so this is concept. So, OF 0.9 in north, less than 1 lah. Which means that the heat normal is 1, 0.9 lah. Correct or not? Northwest, east is 0.23. Red color, anything red you highlight lah. Exam question. Red color you said, okay, if in GBI, then this is the question they're going to ask. GBI facilitator many I saw. Then you see west 0.94, southeast 0.13. Anything touch east is more than 1. Anything tell west is 0.94. Taboo lah. The auntie who buy house, the the salesperson in all the developer tell you don't face west, right? Then I tell the sales lady don't face east. They said no, don't face west. They said who tells so? All the purchasers say so. They said no lah, this is sign says so. You know. Sign says don't face east, not don't say west. My question is why? Why? Architect don't face east and don't face west, right? But I tell you don't face east, not west. Why? I give ang pao. Chinese New Year just over. I have left some ang pao in my pocket. No ang pao, the one. The truth is, it's about sun exposure. On the west sun only heat up towards the later part of the days. On the east side, from if those who are facing east, full glass, my house, 9 o'clock, you don't switch on the aircon, you'll wake up because the heat will come in already. 9:30 will come in already. And this heat will expose all, even though after 12, the sun goes in the other side, radiation comes in, still comes in. Conduction and radiation. Radiation comes in until 6. The exposure of time is much more. So the east is actually more heat. So when you are designing, facing east is less, not west. It's time to tell all the salesperson in all your developer. The sign says so. Not your auntie who buy the house says so. We have been trying to convince them. A few actually agree at the end. You saw this, but majority don't. Okay. So not ngam all the building face east, right? This one easy lah. If it's north, south, east, but if there's in angle, then you need to know whether northeast by west or northeast by south. Cannot remember lah. Those things lah. So more important is 22.5, which is right in the middle of 45 lah. See, if it's more than 28 degree, then it goes to southwest, you turn. If it's less, then it goes to south. If you cannot, then go back and think about it, something like that. So it's more on which side you need to turn the building. Then from there, you need to know which one to need to jaga lah. So orientation, simple. This is the building, this is zona. We're facing south and facing west, not so bad lah. 0.92, 0.94. Correct or not? So the east is 1.2, which is full wall. So correct, you know. People say facing west wrong. They say facing west correct. So the OTTV is 44.65. Remember this figure? This building is 44.65. You saw the building, how it looks like. Full glass, 3.6 for the floor with the beam 600. So it's a 3-meter full glass. We used low east glass because the client wanted a very comfortable and sound reduction because KLCC. So we used low east glass. So low east glass and facing, you got 44.65. Take note, there are more examples given. So the first one, Kao Tim, no issue. The second one is the WWR, we call it the window and wall ratio. Very important. You can see this building, as I said, 3.6. The building is 3 meter. The coping and the latch is 600. So you can see the section there, the red colors are basically full glass building, except some columns and beams. Okay, if I do not use low E glass, don't use low E glass, the OTTV goes to 51, koyak. Okay, 5% higher, 10% higher. Correct, 44 to 51, 10% higher, 10 plus. So, reducing a glass or increasing the efficiency from a normal template, it have to be template or template or laminated high rise. If you do low E, from that full glass, not smaller glass, full glass, you only reduce 9%, you know. 10%, but you spend a lot of money with that 10%. Correct? Most of the green consultant, they don't touch your facade. The first thing they do, they tell you, change your glass. 10% reduce. That's the easiest solution. Sorry, I'm not hunting them, but most of them actually do that because they don't dare to touch architect facade. Most of the architects say, don't touch my facade. So that's the issue. But there are plenty of ways. I think you guys should be aware. Don't use low E. This building goes to 51 because the glass is exposed. But if I just reduce my wall to window to wall ratio, all the window is 15% lower. 3 meter, 300 450 So instead of 3 meter, I put 2.85 the glass or I reduce the corridor, the living room, 15%. 3 meter, 2 point something 15%. 44.65 Same I just need to reduce 15%. I don't need to know low E already. When I reduce the glass, the client actually reduced the glass amount, right? I save the low E, I save the money, wow, the client happy. Of course, the architect not happy. Architect want full glass, 10 feet. Wall to show wall, don't want to see anything. So at the end, it's still you know, not the client, not the green facilitator. Okay, reducing 15% of, these are all based on this building and general information. Reducing your WWR by 15% can save your low E. In general, a lot of people do not know that. Okay, so whether we want to reduce and where to reduce, very important, is the location. Okay, you reduce 15% at south, or reduce all the toilet at the void tak guna rancangan tergendala, is it? Or time to makan? Time to makan can makan, you know. I can continue. Okay, in general like that So project to project basis, it could be 20, it could be 25, depends. If your building is all facing, this is L shape, if it's all facing west, east, then the ratio is different. The point here is it can be reduced low E by percentage. Okay, for this project, 15%. Okay, so you know, So, what is the effective WWR? Still got ang pao in my pocket. No one want to try. What is the effective? If I don't want to do low E, and tutup mata, I know I use this percentage, I can get my OTTV without even get the green consultant or even need to calculate. Hey, anyway, the DPKL, you need to sign the latest one, what they call that? There's a, before you submit your DO and BP, you need to calculate your OTTV and the architect sign. You got someone to do and then you sign, very scary. If you do not know, it's super scary. Okay, and then in your MPPJ also coming, that you need to sign and it's equally scary. So you need to know. Okay, so WWR, what is the percentage that you know that no need to be scary, you know sure 搞掂 one, without the people calculate also you know it's 搞掂, the percentage. What is the WWR percentage? Huh? Whoa, 60%, 40% window or wall. Window or wall. Huh? Okay, sorry, no ang pao for you. 30%. 30% window, 70% wall. That's why if you go for all your low cost, or no, okay, sorry, shouldn't use the word low cost. Mampu milik. Sorry, affordable. Sorry, not mad. Facebook Live, censor can 5-second delay, right? Otherwise I can. Okay, affordable housing. Affordable housing, everything ngam, right? Everything ngam 10%. The cahaya and pengudaraan 10%. And ngam, you put 10.1%. The developer said no, 10%. Ngam, cannot more than that. Because affordable housing, that ratio you calculate is around 30%. And that ratio usually pass OTTV. One close eye, you know it's passed. Lebih kurang. So if your window is 30%, then you can. But we are all not doing affordable housing, right? We do high-end stuff also, right? So you know it will increase, so you need other kung fu. But for rumah selamaku, as long as you keep to 30%, normal brick, everything normal, you'll pass. Okay? Next. Shading device. SC, shading coefficient. There are 3 parts to it. SC1, SC2, and SC3, a bit complicated but still need to go through Architects need to know You need to know so that you know where to correct. Okay? Okay, shading coefficient. Basically the shading. The shading of SC1 is the shading of the glass. The glass itself. In general, thin. When you thin, you shade your own glass. Number 2 is shading device, horizontal and vertical. Very important. Okay? The shade of the glass is the color we determine. Architect usually green, blue, gray, 30%, 40%, that is very long, normal. I think what we need to do now is, what's the SC value and what's the U value, so that we know what's the threshold. I have example here later. Shading devices, horizontal, vertical, acrylic, which is better? Horizontal better? Vertical better? If horizontal better, why? Is acrylic better? Why? We know it's better, but why? We know spacing east is good, but why? Facing east is here, why? So all these are all signs. Sunscreen, sunscreen or sun shading device that is in front, which is better? Sun shading device better? Horizontal better or vertical better? Which one to choose? Which one more economical? That is why we need to know. So basically, it covers the 3. Gray color very important. SC value is a ratio of solar heat gain, radiation. Radiation, we're talking about all this part is radiation. The conduction through wall, conduction through glass and radiation. That's all radiation. SC is the ratio of heat gain radiation through a glass unit of a solar energy which passes through 3 mm clear float glass. So 3 mm float glass, the heat that passed through is 1. If I have tinted it, then 0 point something. Correct or not? Start at 1. So if 3 mm is 1, 6 mm is already 0 point something. Because your glass is, again, second time to ask us to go makan, is it? Okay, 3 mm. Why 3 mm? Because we still use 3 mm glass for our toilet on the low rise, right? 3-4 mm. Still, that is the basic. So we need to know the basic. For high rise, the moment you use laminated or tempered, your SC already 0 point something, already reduction. Okay, 0 point something, usually 0.9 something lah. Ngam lah. So we're looking at the lower and lower. Okay, so these are the parameter, SC1, SC2, SC3, you need to know lah. Because when the facilitator tell you SC2, then at least you know what is that. SC1, shading coefficient. Actual glass, everything actual. This is all not tipu punya lah. First one, look at the red color lah. Exam question, the red color, always remember. Third one, a light, clear, tempered. This is for, with heat soak. Heat soak nothing to do with green. It's just that it prevents the glass from breaking. The ratio is 1 to 1,000. So 10 mm, the SC value, look at SC, is 0.9. So from 3 mm to 10 mm, it reduced from 1 to 0.9, 10% reduction. As simple as that. 0.9, not good enough. If everything 0.9, then koyak, sure cannot pass your OTTV. Okay, we're looking at much lower, 0.6, 0.5. The lower, the better. Blood pressure, always remember, blood pressure. So the moment you put a green color A, 0.59, uyo, 0.59. A simple thin, light thin, from clear to green, it becomes 0.9, 0.6. So that is the shading device, but the glass itself. So tinting can reduce by 0.9, 0.6, 30%, lebih kurang lah. So when someone tell you, changing from this glass to that glass, it will reduce 30% on SC1, not OTTV. OTTV have many parameters. We're talking about all the 6 parameters of reduction. SC1 reduction, 30%. We only compare apple to apple. Whether the whole thing, we have to see in the whole thing in totality. The next one, green, but it's laminated, 0.6. Then, why? Yeah. Very important. People ask, why B 0.69, whereas A is 0.59? A is better than B. Why? Mathematics lah. I mean, all science lah. Nothing. No more. Don't tipu here. Why? The answer is in red color. Is laminated. The first layer is tinted, 5 mm. The second one is actually clear. So it's only 5 mm, not 10 mm. A is the 10 mm green tinted. B is 5 plus 5. 5 green only, the other 5 is actually clear. That's why the SC value is 0.769. Okay? I won't go through lah. Go through 3 hours. I did this in Penang 2.5 hours. So 1 hour koyak lah, cannot lah. Okay, but you see lah, you know. Okay, let's go to low E. Low E is very important. Low E 0.57, but it's clear. But it's low E green 5.2. You see, let's say, you see this very important. E is low E, right? B is tinted, right? A is green tinted, right? Tempered, right? A, 0.59, right? E is low E, right? 13, right? More expensive, low E and 13 mm, 10 mm. The SC is 0.59 and 0.52. You're merely a fraction of changes only. So low E, bagus. This table didn't show it that much. You change the full glass green 10 mm, almost the same thing. So when people say low E, then you say, what is the SC value? Show me the SC value of your full green. Show me your SC value. Then you compare, tipu lah. Not all low E better, you know. Better lah, but marginally lah, 0.52. Of course, your F, if your DGU, 0.24 lah. That one sub lah, DGU. Okay, also if you have DGU in your house, in the building,搞掂 already. Your OTTV all 搞掂 even though it's full class 搞掂 no issue. Okay, so that one is tinted horizontal and vertical. We have horizontal fins. Horizontal fins, not all fins are considered shading device, you know. In the ratio is called X1 to Y1. In this case, the X1 is 300, the Y1 is 1002. The ratio is 0.25. 0.25 is not a shading device. This coping, 300, sorry, back, belakang, back. No, next. 300 versus 1002, the ratio is 0.25. That shading device is a coping. They cannot call a shading device tipu, mind, waste money, waste client money, aesthetic only, not for shading device. The client find out you're in trouble. Okay, you tell them this is a shading device, then tell you no, this is a coping. Because there's a formula for your coping. Okay, and there's a ratio. To start, the ratio is 0.3. Anything less than 30% ratio is not a shading device. Mind saja, aesthetic reason. Okay, it's time to check whether the screen at the PAM center versus the glass got 30% or not. Go or not? Okay, sorry, architect not around, right? Otherwise I cannot hantam again or 2 round. Ratio 30%. Why? Because this is a formula. In order to get the lower the better, right? See, if the ratio of X1 or X2 is 0.3, then your SC2 is 0.7. So you factor the 0.7 in. The lower the better. If it goes to 1 to 1.2 to 2, the factor is 0.6. Okay? The longer the ratio, the better the shading devices. As simple as that. So in this example, fail, tipu, copying only. 600 over 1002, 0.5, 0.5, then you hit the SC value that used into the formula. Okay, in general, architect need to know only one thing. Anything less than 1.3 tipu cannot. More than 1.3 can for 30%. From 30% to 50% to 80% or 1.2, you look at the ratio of reduction. Worth or not. Cantilever 600, your client already jumping. Your 1.2, cantilever 1.2, he will throw you down, you know. So you need to ratio. So ratio of 0.8 to 1.2 is quite difficult due to margin. So we are looking at 0.3 or 0.5. 0.5 still can, 600,000 still can. Correct? Okay, look at that region, 30% to 50%. Then your shading device works. And it goes to the east side. From the east, and then you go that, then you help. So SE2 is 1. This one, very important. Some RC coping, or this is RC coping, this is not shading device. Get the term correct. The shading device, the so-called shading device is 600 above. We saw many buildings, but the coping is higher because they want to tie back to the beam line so that the beam might come up cantik. Engineer said, architect lah, so I know lah. The engineer said, oh, down beam, come out, don't come down. You come down extra cost, then only you come. Otherwise, your coping, you want a shading device cannot hold all money lah. So say, okay, put the coping, the shading device on top lah, at the beam level lah, like that lah. Ayo, belakang. Like that lah. That one mind lah. Because your Y1 now become 2.1, you know. Then your SC.1, this one become coping again. Your shading device, your engineer tell you to that. He said, cannot lah, engineer. My shading device become coping already. Okay, so also you need to know lah. All this, today a lot of things that to share lah. So try to remember as much as possible lah. Okay, this one simple lah. When it's a pitch, you get the lower side lah. Simple. Which is better? Ang pao again. Which is better? The left or the right? I mean, depends which is left, which is right. Left, right. Which is better? The right is better. Some say right, some say left. Same lah, actually. The neighbor wife more cantik or your wife more cantik? Same lah. All wives same lah. Sorry, hantam people again. Okay. Same, because they talk about ratio. It's about ratio. X over Y, X over Y. Ma. The ratio on the left is X over Y, 600 over 600, 1. 1008, 1. Sama. So the calculation, the ratio, same, 1. The first one is 0.3, the second one is 0.8, the next one is 1, right? You jump into the third column. Belakang. Sorry, this one can only go forward, which is good. Oh, up button. Now only you tell me. Okay, thank you. You jump to this segment, this column. So your percentage reduction more. Okay, so but same. It's all about ratio. We are currently doing one building. Subang, architect, not here today. Same series of fins. And the fins, wow, 1 meter. But over a gap of, I think, 400, then say, man, sear kan only you reduce your screen to half a 500 save you another 500 For the entire building is a lot, save a lot of money Same OTTV same. You just mind saja. Science Okay, next, which is better? Top or bottom? Quiet already. Scared already. In OTTV calculation, all same, except this guy, the upper right. Because in OTTV calculation, it's all, if in simulation, the bottom one will have H. But it's OTTV calculation because it's just calculation. Okay, parameters calculation. Okay, it's a shading over window. Shading over window ada, shading window ada, shading window ada. Extra comes down, so the vertical fins, the vertical shading comes in. So it's better. Okay? But in simulation, the bottom one is better. Okay? In general, what we know, don't worry, we are all architects. All can solve the problem. Cow team, good enough. Okay? Some of the work. This is the graph and then I extracted from This is one extracted from. This is vertical, same concept. X over Y, X2 over Y2, ratio 0.3. This is vertical. Okay, vertical need 2 sides not 1 side. 1 side cannot tango. 2 sides. 2 sides, 1 long, 1 short. How? Architect rhythm 1 short, 1 long, 1 short, wave. The shorter ones that used for calculation. The longer one, you're wasting like time, money. In terms of sustainability, aesthetic, not here, wrong forum. Aesthetic, someone else give the talk. But the calculation is based on the shorter one, unfortunately. So take note, you have a ratio again. 1 short, 1 long, 1 short, 1 long. For horizontal, is every single window. For vertical, if it goes down, is the shorter one. The PAM center, all consistent, no issue. Not supposed to kutuk him. Okay. Which is better? Horizontal or vertical? A lot of questions today is like back to school, very scary. Prepare on orientation. Wow, you're good. Top student are you? In general, horizontal is better to vertical in all facades. Science again. The factor of 0.3 for horizontal and vertical, you see, is more, the horizontal divisor is 10% more effective for all around, anywhere. South, anywhere lah. You look at the numbers on top, 0.82 to 77, 0.77 to 0.71, 73, and etc. On top is a vertical, below is horizontal. If you use a fin on your horizontal window, just 1 side, versus your 2 sides window, which is more expensive and sometimes longer, the horizontal is more effective by 10%. Coupled with the money spent for a vertical on 2 sides, the client will jump to you again. If any developer here, then koyak, all the secret koyak already. You cannot have vertical fins anymore. So this is so horizontal is always 10% more effective, okay, in any angle. So go back to my project. 51, just I mentioned, right? If I don't use low E, I koyak, right? If I don't use low E and I have a 1 meter cantilever, now I don't have 1 meter, a 1 meter cantilever, 1/3 lah. 1 meter, 1/3, right? I have a 3 meter wall, 3 meter window. Hey, my OTTV47 pass there, 搞掂, settle. 收工, no need OE. Okay, so can be done. Acrylic, same concept. So acrylic is better. Acrylic means horizontal and vertical. You calculate 2 times. If you do it, see the percentage from 82 to 77 to 71. From 82 to 77 is a lot. So you do both. Okay, PAM, acrylic. Size very short, very good. Ratios very good. So the efficiency is much better. Okay. Horizontal and vertical, if I, is it, this one? Can. If I, the red color, if I added vertical fins at all the windows that comes out, if I add of course didn't add then the OTTV becomes 44. Goes back to equal the low E, you know. So if I take out the low E, I put the horizontal or relay pass. I put the vertical, sama dengan low E, no need low E. Okay, but of course it affects your aesthetic lah, understood? Sunscreen. Aha. If I put screen, a simple screen, vertical screen or horizontal screen doesn't matter, on top of in front of the glass, which means that you see lobang lah. Let's say 30% void. 30%, calculation based on, 30% void, 70% screen. So you can see 30%. The SE3 is 0.3. Oh, very low, right? The lower the better, right? Just now, all the SC, don't know whether you realize, 0.7, 0.7, 0.7 something, 0.6, 0.7. To reach 0.3, or you 1.8 meter cantilever, you know. You know. If the opening is 0.3, your SC is 0.3. Correct? So you can actually control through openings. That's it. No formula. What is the opening? What is your SC? So if I have a 70% void, 30% screen, which is let's say 500 then I have 50, 1.150 opening, the gaps. My OTTV is 44. Many ways to move the OTTV to 44s, you know. Not only low E, so the screen can do the job as well. So which is better? Vertical, horizontal, group as one. Just now you know vertical, the horizontal is better than 10%. So the horizontal better, or the sunscreen more is better? Which one? Sunscreen better. Why? Sorry, must I, why? Otherwise no ang pao. The reason is vertical and horizontal, that the graph tapers. I didn't explain, no time. Where's the graph? Hilang sudah hilang. Ada hantu it tapers. This is the SC value and this is the ratio. The ratio 1.7, it tapers. Correct? The long 1.7 cantilever, 1.8, 1.9, 2 meter better than 1.7 very fractional because of the tapers, because of the graph. No time to explain, sorry. But agak-agak, you know today's more on concept But the shading device on the screen is about the void. How much void you want to open. Okay? From the red side, you say more screen, perforated, more solid. It's up to you. Okay, the void is 20% times 0.2, everything comes down. There's no limit. Whereas the numbers from the graph, it tapers. The max you can go is 0.34. It's very high cantilever already. In general, we talk about 0.7, 0.6. So if you want anything 0.5 below, the screen is a better choice. Of course, more expensive lah. Okay, so you want to take a break first or continue? Already continue I got, this is only like 30 stuff. I got 120 slides more. Continue Okay. After this okay, can. Okay, let's continue. OTTV, next is glass. Just now is radiation. Take note lah. Now is conduction. Conduction, you touch the glass. Simple, it conducts. Okay, the heat to you. So how you conducts, okay? So conduction, reduction is through U value, okay? The resistant properties. With your U value lower, greater resistance, it conduct lesser, as simple as that. So you're looking at U value. The same chart that I give just now, U value 5%, 5.7, 5.1, and it goes down. If you look at the DGU is 1.5, and then the green is 5, the low E is 2.8. That is the difference. The low E shading, not much, because it's clear, radiation. Correct or not? Versus green. Green is SC, radiation. Conduction, a low E with a coating is better in conduction versus in radiation. These are the technical things that you need to know. Not all low E better, simple. The U value is better compared to the SC value in terms of apple-to-apple comparison. Okay, so you look at that. So clear is 5, and how much reduction? Of course, all your DGU is 1. Okay, why DGU is 1 point something? DGU conduction, right? DGU in between. Gap leh. Conduction cannot go through air, especially vacuum. Argon gas lagi. No conduction, right? No conduction, 0. Then why 1 point something? Sorry, a lot of questions asked today. Thermal bridging, the glass need to be whole, right? Thermal bridging from the side. So it's still marginally 1 point something. 1 point something is considered very low for U value. Very low already. Okay? Okay. So, U more important or SC more important? Both also glass. Which is better? I think it's time to break. Sleep. A lot of people sleepy and hungry. Which is better? Let's go through until OTTV, then the advanced OTTV, the roof U value, we do it later. So which is better? The roof U value or the SC? Very important question. So which one you look at it first? The radiation first or the conduction first? Radiation, correct. The radiation carry more weights. Tackle the SC. U value comes secondary. Of course, go concurrent better lah. But the SC, more important. Okay? SC is the radiation of glass. You don't need to touch, don't need to conduct. You stand 2 meter full glass, you can feel the heat. Radiation. That is the one that you need to tackle. SC. Okay? Goes to wall. Same lah. Wall. These are the typical wall lah. The first one is brick wall, lightweight block, brick wall, concrete, aluminum composite, aluminum panel composite with insulation. Normal brick wall, the middle one, middle left, is U value of 2.7. Agak-agak lah, 2.7. Lightweight block, 0 point something. Lightweight block is a lesser thermal. You break, you heat up with lights, very soon you have your clay board, whatever, clay, right? Or very hot, right? Lightweight block, you light heat. Go to the previous slide. Oh, got question? Very good. Sorry. Yes, 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 definitely. From the formula already, SC is much more efficient. Yes, correct. Rightfully mentioned, the formula, see, the denominator is the constant, sorry, constant is 15, constant is 6, the constant is 194. By this formula itself, the SCA, again, the SC is more important. But let's don't forget about the concept. Let's forget about the formula. More important is the concept. If you look at the SC and the U now, you know, radiation is much more, and the ratio of reduction, U is 2 point something, the SC is 0 point something. You use a 0 point something to times your whole OTTV formula versus a 2 point something to times your whole formula, the 0 point something carry a lot more weights. In general, in general. How? Time's up. Many times, so how? Yeah. Continue a little bit. Let me finish the OTTV. Then the next chapter will. I need to speed it up, I know, but if you don't talk the concept correctly, then koyak also, correct? Leave this whole saying that nonsense, then koyak. I mean, then English, tak boleh. Then makan no? Really cannot? Really cannot? Sorry. Let's go, makan! Oh, sorry. Someone need to announce.
Okay, so it's clear somebody wants us to stop right now and go to have our makan. So just to give you a brief, let's first and foremost give a round of applause to our speaker, Architect Michael. Lively and entertaining. What we will do is we're going to take a 30-minute break, but I think we should be back a little bit earlier, say about 10:50. So we'll take a 20-minute break instead. Refreshments are served on level 1 outside the gallery and level G. Okay? So instead of 30 minutes, please be back in the hall in about 20 minutes from now. And we'll continue. In the meantime, we'll check and see what's causing those glitches. Okay? Thank you so much. Pergi makan. Selamat menjamu selera. See you back in 20 minutes.
The lower one, 0.3. 34% heat absorb. So you absorb 33% heat, your black car is hotter than your white car, versus your black 95. Once you absorb, the first surface will have thermal conduction to the internal, right? So if your building is white color, you're already much lower than your 90%, 30% lower in terms of, so you cut at the surface before the conduction even takes place. So your color very important. How important? OTTV 44.65 toner. White color. If I change it to gray, it fails. From 44 to 52. 20% increment. Not salary, OTTV. Okay? 20% from 44 to 52 just by changing color. You do all sort of low U value, all this low E, no, do everything. Just because you insist on black color, you are 20% handicap already. As simple as that. Not to say that every green building must be white. Nowhere to put your gray, nowhere you put your white color. Okay? It doesn't need to be white because they are 0.3, they are 0.4. Anything darker is 6.6 onwards, then koyak lah. So very important. Having a dark facade, you are 20% handicap from start. As simple as that. So your OTTV, let's say 50, 20%, you're 60 something just because you like black color. A lot of people like black color, right, Sini? Architect ma. So anyway, so take note lah. Color make a very significant changes. Okay, so nowhere to put lah. So in general, to conclude OTTV, conduction 8 to 9%, it's different from GBI figures. I don't know about other tools. This percentage is purely from my company, 15 years of experience, the data that I have. So it's based on my company data. Okay, that's it. Nothing more than that. We have completed more than 100 plus building. So this is the figures. So solar heat gain The SC is still very important. 50 to 60% of it actually go through there. Then the window SC value, okay? And then after that, U value. Then after that, your U value of your wall, which is cannot do much, either brick wall or light brick block, but the color. The color, overall 20% of that part, okay? It all depends on 20%, but overall you need to look at the glass and this one. So in general, overall it's around 10% difference, the color overall. Okay, summary. Base stoner, 51, fail. But if I put low E, 44. If no low E with 50% reduction of WWR, window wall ratio, 44, same. If no low E, I don't want to reduce my glass, I want full glass to see KLCC, extend my hood by 1000, still meet the requirement 47, get less points only. If I put an acrylic, 2 points. If I put a sunscreen with 7 dependent void, same. If I change to low dark color, then I fail again. Okay, so these are things that I think architects should know. So you know your perimeter, what to change, and what are the priorities. Okay. Okay. I'll go much faster now. Advanced OTTV. Just now one basic. Basic you put a square box, very basic. But there are a lot more. PAM Center. This building not done by me, so I have to declare first. Other building show yes the screen works If cannot works, then koyak lo, platinum building, right? So the screen works. It's an acrylic. There's a calculation later I'll show you. But building have cell shades. Okay, the lobang, that lobang there, right? The lobang, they are shading over a building. It's cell shade, internal shades, courtyard and all that stuff, shell shades. Okay, so these are the things that actually in OTD calculation just now, you talk about window ratio, you talk about U value. Where are the shades? If I design my building like that, the diamond building in Putrajaya, it shells the higher building actually shades the lower building. How to do that? Yeah, so this is the formula. It's called local shading, and there's a ratio. If the ratio is, this is a ratio from top, courtyard, ratio 1 to 3. If the ratio is more than 3, anything below, okay, is shaded. Anything above is not shaded. Don't worry, I'll give example. Courtyard, light well, 10 feet and 10 feet, 3 meter and 3 meter 10 feet, 10 feet. Your floor to floor height, 10 feet. Ratio 1 to 1, right? 2 floor down, 20 feet, 10 feet. 2 to 1, right? 3 floor down, 30 feet, 10 feet. 3 to 1, right? The first 3 all kena. Okay? The 4th story onwards, 4 ratio 1 to 4, right? All cell shaded. Because the courtyard 10 feet cannot penetrate the heat down on the 4th story. So that's why all the courtyard, the light well, that you go all the condo, the first 3 story, all light, very good light, right? Also very good heat. Okay? The 4th floor onwards, the heat will stop penetrating. So in calculation, for all the calculation, anything on 4th floor below, ratio 1 to 4, 1 to 3, all the window are all considered wall. So the WWR goes up. So it's actually a shaded area. In general. Today, no time to go detail. That one is if on top, ratio 3 to 1. Condo, you all know like well, condo, 3 story down, assuming it's 10 feet to 10 feet. This is vertical, PAM center, plan. Ratio 1 to 1, easy. I have opening 10 feet, anything go down 10 feet, all kena. Simple as that. But the top 10 feet, then you have to see. So it's actually top and side. So ratio 1 to 1 for side. So PAM center, OTTV cell shades, these are the area that shell shades. Okay, without calculating the cell shade is 45. The submitted is 45 with 45 with CVA also 45. Then I got permission from the facilitator to test the cell shade, which we did. These are the area, The red area, the lights will not penetrate through, which you can see much further inside, correct? Further out, you can feel the heat. When it's 1-to-1 ratio, further in, you don't really feel the heat, okay? Be it radiation. So from there, if you clear all the cell shade, you actually have 6%. So 6% reduction because of the cell shades from the building. So you need to know what can be cell shade, what cannot be cell shade. These are the perimeter, the courtyard can, inside courtyard can, the niche in the building, all these things can. Okay, sorry, have to go very fast, so I cannot explain one by one. But in general, building can cell shade, and insist your green consultant to calculate the cell shade, because the cell shade actually reduce your WWR, window wall ratio, from higher to lower, and it does work, the PAM center. Vertical green, the vertical green is your SC3 screen. Instead of having screen, you actually have greens, and your greens have a ratio. How many greens versus how many opening. It has to be real. So by the time GBI go and assess your building, you need to see the ratio of green versus not green. You can actually factor that in. If you scared, factor lesser lah. Let's say that one is 50%, put 30% lah. So some of the blind mati also not so bad lah. So you put in your SC3 there, then you can actually reduce your WWR. Okay. This building won the National and ASEAN Green Building Residential. Next week, award will be presented. It's our building. The facade, the green, also reduce the SC2, SC3. This is not our building. PIPV generates electricity, generates solar energy through the sun, through radiation. You can actually use it as SC3. Okay, the percentage of void versus solid effect. If you goes to MGTC building, the PV panel, PIPV panel at the roof does actually reduce a lot of heat through the roof. They have low E and PIPV. It does reduce. Water. This facade is also ours. The behind the panel is actually a water tank. Use water as an insulation to reduce the heat on the west side. Of course, that is actually a vertical wetland. The toilet, the discharge from the toilet is actually used to circulate to reduce for the water movement. It's a wetland, but it's elevated. Water. This same building, it's a mist system to irrigate. So they're actually using the water to cool out the facade, like your mamak lah, your mamak, same thing. But it will cool down the ambient and cool down the facade. So these are the advanced OTTV, just like calculation, but these are all more advanced. That's not ours, of course. Water facade, they use the water to reduce the heat. Material, not only bricks, you can actually have more playful certain materials. So this material has an air gap inside. So with air, it's like cavity. Then talk about conduction only through the contact points. So will be a lot more because air itself is actually a conduction. This is our version of PAM building competition 15 years ago. Of course, we kalah. Otherwise, you'll build this. But I think architecturally, of course, I think this building more stunning lah. No question about it. But I think let's look at the sustainability features that we proposed 15 years ago lah. 16 years ago actually. Some worth to check, and I think still valid now. So what we did is we have a recycled water right at the top. Recycle, 2 tiers. One tier is potable. The other tier is grey water. It's a toilet water. Toilet water actually use it for irrigation, wetland. From the wetland, it goes down to the suction tank, lower ground, pump it up to use it. So and this planter box are actually collect rainwater. The rainwater goes down. So the whole thing is actually a closed loop. And when it rains, the water can actually, when it hot, you actually pump the water, open up the valve on top to throw down the water. The water actually can clean the facade, and it's a loop. So basically, and on the bottom, we actually use the rain turbine. Whenever it rains, the cutter throw out water free, right? We put a turbine there. The turbine actually generates energy. The energy goes back to pump. So it's a closed loop of wetland, your irrigations, green, a facade use green and water to close, and then generate water through drains. So this is the sustainable facade that we proposed 16 years ago. Okay. Green roof. So OTTV is just the basic. There are architects need to do a lot more. So these are the examples that some of them from our company, some of them are outside where you can actually do a lot more. And you know the concept, then just ask the green consultant to tell them what is the value and ask them to simulate, have them calculate. Then at least you know where is the basics. Okay, green roof. Sorry, I'm late again. Green roof, there are many types, very fast. In general, they have insulations through water features and pool. Water itself can actually act as an insulator. Okay. Double roof, you actually raise the deck. You see this one, you raise the deck. So the deck itself is a roof and RC below because of the swimming pool. So the raised deck is called a double roof. Insulation, rigid type, later I'll go through, rigid type. Bug insulation, either radiant barrier, radiant barrier or spray. Oh, one more, reflective, missing. Double roof, a roof over a roof. This is a deck, double roof. Insulation, turf as a, so there are many ways to insulate the roof through calculation. The question is, which is the best? Having water better, raised double roof better, rigid better, turf better, double roof, same double roof better, or insulation better? Insulation bug barrier better. Which is the best? OTTV, you know which is the best? Which one to tackle first, right? Which one? Double roof, yes, great. Double roof, you stand below a rain tree, same lah. Okay, and then by the time you hit the ground, a lot of things have already been shielded. Okay, but real example, this is a shopping mall near Bukit Bintang. This is a real project. The heat, orange is 50 something. This is around 50 something. This is a metal rack, metal deck roof. 50 something. The moment have metal roof, double roof, it goes down to 30 something. 20 degree, just have a roof. Nothing inside, no insulation. No insulation. A roof over a roof, 20 degree drops. Real example, real project. Engaged by a client to do a real project to reduce this heat that comes down. So from the top is 50, by the time you radiance down, you hit around 40, cannot use the area. Now 30 something, you hit down, you reach 28 with a fan, with a fan and control movement air, you can actually use it without aircon. Okay, just by putting a roof. Cost, that one, of course, not efficient. Cost, architect don't look at cost, right? No lah. You need to balance. Certain area you need double roof, certain area you need rigid, certain, no choice. Just like OTTV, you cannot whack everything one solution, you need to balance. Yeah. Both metal. If one concrete, one metal, even better. I have a graph actually. So this is much better. Better solution doesn't mean that the solution. Just like this example, rooftop. There are many combinations in just one roof. This is the graph. The blue color is actually the solid RC. The red color is actually the metal. The airspace required, need airspace. The gap cannot be 2 mm or 20 mm. They want tipu. Because why? The conduction still happens when you have columns to hold them. and radiation still happen even though it's less. The further is the conduction reduction, the better it is. So there need an airspace gap in between the air change per hour. The engineers work lah, but I think we do this easier lah. This is a chart. Whatever the roof angle, okay, at certain level on top, what is the average speed on the air and what is the air change? No need to know. Don't worry. This one engineer draw graph to sketch architect. Very important is our air change in our climate in Malaysia is around 2. So around 1 meter gap. Counting. For RC less than 1 meter. For metal slightly more than 1 meter. Okay. So that is all we need to know. Don't worry. That's all we need to know. So the gap in between 1 meter. So for a swimming pool just now we did 1.2, right? You put a deck 1.2. The gap there. Counting. Counting. Okay, that's all you need to know. You ask your green consultant to calculate, the same answer will come back. Counting 1 meter. Okay, so let's go to the second type, rigid foam. Senang lah, you know this lah. The cutter is exempted lah from this insulation. So pros and cons the one you know lah. I'm not here to talk about that. I'm here about the insulation. Next question is, can it be installed below? Can I install below? When you install below, it still reduces the thermal conductions into your building because thermal bridging, the heat will heat up the slab. With the slab 40 degree, 45 degree, it goes down to this beam. And because it goes down with the higher level, the conduction, the U value reduce. This one, it hit this before it goes there, so the conduction is much lesser. So when it goes down below, the property reduce. You need to do a simulation to confirm that. You cannot have a static calculation. The answer is can, but it reduces the property. This is the rigid insulation. This is the bulk insulation. This compressed, this will reduce the property efficiency. This is the correct method, a Z spacer, so that it's consistent. Also have the pros and cons. Radiant barrier. Radiant barrier or reflective, very important. A lot of people say reflective. There's actually 2 types. The top one, radiant barrier, is actually reflective surface with an enclosed bare space. The second one is reflective insulation, is usually laminated with woven foam inside. Very simple. The thin, the chipu one, that one, chip one, that one is radiant barrier. The one with inside where you hold very hard one, got air, got woven things, that one is a reflective insulation. The reflective insulation inside got woven, right? Got fiber, got air gap. Usually that material itself is actually a thermal resistant product. Okay, so itself has some R value. Whereas the tipo one don't have 0. The heat just go through. No, this one to hold the insulation only. No issue. No function. But if these 2 material work together with an air gap, enclosed air gap, no ventilation, that air acts as an insulator. That provides you the insulation. Okay? Example, you go winter, you pump air into your clothes, you feel much better. Of course, provided there's a silver lining below, you feel much better. Cooler. Same concept. Okay? So these are the 2 materials, radiant barrier and reflective. Very, very important. The rest, the one rigid form you put in sure meat is how thick and how density. The bulk is how thick and how the density. This one got a little more trick because you need to reflect 95% of the heat to meet the requirement. Otherwise, it's not a core radiant barrier. It's not, if your reduction less than 95%, it's actually not considered reflective, not considered radiant barrier. All the figures cannot pakai. It has to reflect so that the air itself is a thermal property. Okay. Spray type, spray lah, same insulation. The good thing is you can spray anywhere lah. So turf, just I mentioned. Yep. Turf as it, no issue. Water, as mentioned lah. It's the same project last time This is our project where you use many types into the roof lah. Okay, roof yield calculation. So sorry lah, a bit fast lah. Rigid form, very simple. You calculate from the top to bottom. The top is the external surface, is R value. R value is the opposite of U value. Okay, 1 over R is equal to U. For U to be lower, the R has to be higher lah. So the R better, R is thermal resistant. If you resist more, then the better the U lah. Correct. So R is resistant. Sorry, R is resistant. U is the balance. So for thermal, for external surface, it's a default 0.04 for your R value. Cement-screed depends on the thickness. Okay, no issue. Waterproofing, very little, 0.00 something. So don't use waterproofing as thermal resistant. Tak boleh pakai. Then the expanded polystyrene, 60 mm. RC step, internal surface, default. Then you put 1.8. You reverse it, 0.5. A requirement 0.6, then you meet the requirement. So for concrete, there's only two solutions. If you take out the concrete with the water, concrete with turf, if it's purely concrete, there's only two solutions. Either use insulation or double roof. Okay? Whether you want a protective screed on top, Dewan is architecture detail lah. Some put gravel, a lot of ways to hold the insulation. The insulation floats. You need to hold them. At the same time, you don't want water seep in and then got waterproofing issue. So that's detailing lah. Detailing not here lah. Here is insulation, but there are many ways. This is just one of the ways. Radiant barrier in reflective insulation. If you don't know this, download. It's called Guidebook How to Calculate U Value for this. So kanchiong. Okay. There are 4 examples. Just talk one. Okay. So this book actually helps you to calculate what is the value, the R value of the air gap coupled with your reflective or the radiant barrier. I'll skip this law, no choice law. Goes to example 3. Example 2 better, I think. Yep, example 2. External flame fixed, metal deck, fixed, not fixed, depends what kind of metal deck lah. Lysac, for example. Have to angkat a bit lah, they sponsor today. Then the mesh insulation, depends what mesh insulation. Radiant barrier, not reflective insulation. Radiant barrier means the cheapo one, the flimsy one. Single-sided, facing down, because you need the reflective coupled with the air gap. In this case, the upper part is actually used for the mesh insulation, sit on it. So you put reflective there, you're wasting client money. Tak guna, facing down. But thermal resistance 0, but there's a 75 mm gap here. So this is 75, there's a space, there is a value here. I'll put a plaster board in that. How to put a value? You go to this thermal, emergency 0.03, which means that the reflective is 97%. 95% on top baru boleh guna. If the reflective, the E that the manufacturer give you is less than that, can throw down and drink, tak boleh pakai. Okay? So 5 degree, because of this 5 degree and the gap is 75. 5 degree, 75. So your R value is 1.3. You put a 1.3 there, 0.33, then you got 2.9, then U value is 0.35. Okay? There are examples with attic. This is your attic space, your triangle space. The triangles have the default default figures. So whether ventilated, not ventilated, very important. This non-ventilated, ventilated ratio is 1 to 600 opening of your ceiling space. 1 to 600 in, 1 to 600 out. You need to have a air to move for attic. Okay. Non-ventilated is 1.9. Ventilated is better. Okay, last few slides. I know the thing already. All these things we need to know. We know what you know, but how does it really affect? Because there's the Energy Efficiency and Conservation Act. You should know, right? Gazetted last year, implementing this year. All existing building kena, all retrofitting building kena, all new building need to do. Okay. So what that need to be do? all new building needs to perform certain BI. Office, for example, any BI need to reduce to 150. And a lot of people ask, engineers problem? No, because there is a relationship between OTTV and BEI. Your OTTV comes down, the same aircon will come down. Okay, so we play a very important role. So, and if you don't comply that, it's a 10,000 fine, 100,000 fine per year. Okay, every year. To the building owner, not to us. So, but if you design the OTTV and the BI correctly, of course, no issue. There are 6 categories already being gazetted, implementing. Office, more than 8,000 big office. Education, healthcare, hotel, retail, and data center, all moving up in the industry already. The rating, you need to meet certain rating, 3-star and above. Anything more than lower than 3-star, you get a penalty. So we're talking about, depends on typology, 1.3 to 1.6. Rolling out, and I'm the technical expert group in the committee under ECA, representing different organizations. But more important is I'm advising them on the passive side. You look at all the things, none of them are architects. So all the passive way of doing things, I'm in there to share how to do. So with that, thank you very much. That's all. Sorry, delay, more easy.
Okay, thank you so much for the very entertaining and insightful presentation. Does anybody else want to give a round of applause? I thought someone was, okay. And now, because we're running a little short of time, without further ado, I'd like to re-welcome Miss Wendy Eng back onto the stage to continue with her presentation as well. Thank you.
Okay, good morning. Still good morning. Back to me again. Okay, so let me do some introduction about my background. I'm actually Wendy, so you all know that I'm actually from NS Preschool Lysat. I graduate from business school, but I can say somehow or other I have some construction blood into me, literally, because my father is actually a tractor driver. Then inspired to my brother. So my brother is actually a work contractor. So every time dinner, I always heard about like what cubic meter, rebar. That's always our topic in my dinner. Yeah, so somehow it's also inspired me a bit that I joined Brusco in year 2011. So during I joined Brusco, I was in the PEB business, pre-engineering business. Then after that, I started to explore myself to a midstream. So if you go back to my presentation before that, midstream is the coating line. So now after 7 or 8 years in midstream, then I transferred myself into Lysat, so now I call Lysat as my home. Yeah. So to enhance my faith into construction, I actually married a civil engineer. And she's the civil civil contractor now. Yeah, but more or less so today, okay. So today we are actually going to explore how these often steel materials have actually shaped our world and also leading in the sustainability. Okay, so back a bit about history, a bit how this steel come into a construction. So back in year 1871, there's a Chicago Great Fire destroyed about 17,000 of timber building, and I think killed about 300 people. So from there, actually, the Chicago government start to governance that all the materials come to building must be non-combustible. So they already start the regulation. But thanks to now our technology and also our Malaysian government, so we further enhance on the fire safety by actually governance like BS 476, BS 8414 as well. So, but today we are not going to touch any topic about fire. We're still back to the steel, the sustainability. So the first major steel used in the market, in the construction was actually used to bridge. So the first steel bridge is actually Brooklyn Bridge in New York. Then after followed by the well-known Eiffel Tower. So back to post Valentine yesterday, a bit love story about the bridge, the steel as well. So if you watch Spider-Man, then where's the Spider-Man, the Peter Parker saved his girlfriend, Jane? It's actually seen in Brooklyn Bridge. Yeah. And also, Eiffel Tower is actually an iconic romantic building. So everyone would like to go there and take some romance photos. Or anyone have put your love lock in the Eiffel Tower. Okay, so yet, steel is not only strong, rigid, but it also can be one of the iconic to actually show how the dreams come true. So furthermore, 20 years in the 20th century, so steel was actually introduced as one of the primary construction material in the market. And actually steel also brings us more nearer and nearer to the sky. Like how steel bricks the dazzling high tower like Willis Tower, 108 towers and actually 108 story and actually 442 meter high. Okay, so today steel is not only in agriculture building or garage, it's actually more become actually surrounded by us. Every shopping mall, high rise, even hospital. It become even our day-to-day living space. Wherever place that you go, it actually can see steel. So from public infrastructure to skyscrapers to our private residential, even now we can see more and more in steel. So whether you actually how Malaysia, how much that have we actually adopt steel in our construction line. So remember our old kampong days house. So this is how my grandmother's house looks like exactly. So they are actually very cute, very charming, but they are actually not energy saving because they may need to use a lot of aircon or they may use a lot of fan inside the building. And yet today you can see steel is become more advanced with all the technology. So we're actually able to build lighter steel and we're actually able to give the steel more charming, which is actually steel can be erect much more faster and much more easier compared to the others material. So it's actually allowing for faster, safer, and more sustainability building practice. So steel is actually in our life that we can't even like let go or we can't even like. So from the humble corrugated steel to a rural home to the complex framework of shopping mall. So everywhere, not just about the aesthetics, it's also about the functionality. Okay, so the versatile of the steel is actually, the versatile of the steel is actually an ideal material for almost every application. So from here you can see from door frame, from truss framing, floor decking, louvers, fencing, ceiling, everything is actually built by steel. Okay, so steel is actually written in our life simple because there's no any other material can compete or to have the combination of formability, versatility, and also the strength of steel. Okay, so actually steel allows us to build faster and lighter building, and it's also how steel impact in sustainability. So today sustainability is a buzzword of century. So everyone loves our planet, right? So anyone doesn't love our planet? You can raise your hand. Of course, no. Okay, so well, actually, steel is doing his part lah. So from his end of life, it's actually have a very, very, very smaller environment footprint compared with the many other material. So actually, still getting smarter and smarter. So we're able to create stronger and durable, lighter steel. So this means you have less material, less energy consumption, and smaller carbon footprint comes to construction. So it's actually giving us steel something like a diet and workout. We keep on switch them. Okay, so looking at this chart, you can see that steel is actually much more lighter weight. I mean 3 to 9 times lighter weight compared to this other material. So what this says that? This says is actually steel are actually the most efficiency sustainability material because it's a choice and very flexible and actually very lighter. And actually very good for renovation or either refurbishing because steel is actually, it can add extra floor to your existing building without added any extra loading to your existing foundation. Okay, so it means it's also giving you a less carbon footprint. So imagine the high-rise tower, you build a high-rise tower with no noise, no waste, and very fast, and you meet the target or you meet the construction time. So this is the beauty of off-site prefabrication, we call it PEB. So means we're going to produce or we fabricate the steel in a controlled environment, then we send to a site. It's something like adult Lego. We're going to fix piece by piece and screw piece by piece. Okay, so it basically inside, right, for steel, right, it's actually reduce waste to almost zero. Because whatever steel that you left, you're not going to left over any extra steel on site because everything is already prefabricated and sent it to site. Yeah, so steel grade strength, also a lot of creation and flexibility. So provide architect with greater confidence in construction a complex steel building. So actually steel can withstanding anything, various forces such as wind uplift, wind load, and also seismic activity. So with the coating technology also actually prolong the steel lifespan and give you a very, very minimum maintenance to your roof. Okay, so there's also a better thermal comfort, just like the color selection that what AR Michael just now mentioned, and also better energy efficiency, where you have the system to build up to give you a cooling indoor environment temperature. Yeah, so yes, steel is actually like a superhero material. Yeah, it's something like Spider-Man. I like Marvel. So we are talking about a material that actually can recycle and reborn again and again without losing its strength. So means today I use a steel. If I don't like this building, I'm going to refurnish this building. The whole waste is going to go into a recycle without any waste. It's 100% recyclable. Yeah. So, comes to sustainability. What steel play a role in sustainability? So, steel is actually a very, very good team player. They are a solar-ready roof. They actually can go for green roof. They are also lightweight for your steel framing and your structure, and also a decking for your high-rise projects. So, to sustainability. So, all the metal deck profile, most of the metal deck profile that you see in the market are actually solar ready, where all our ribs are actually ready designed for the solar clip. So means an example, like if let's say I use a concealed fixed corrugated profile. So since it's a concealed fixed, I don't want the solar clip to penetrate the roof as well, because it's already concealed. So there's a solar clip design ready. You can see from the picture here, that is only just need to clip on my roof. And just need to click on my roof, yeah. So without any penetration. So why when it comes to solar roof, we don't like to have any penetration on the roof? Because you do imagine if let's say there's a leaking on your roof, but yet you have a solar panel on top of your roof, you're going to be very hassle. Yeah, you need to remove the whole entire solar to repair the leaking area and have to replace your roof in again. Yeah. So normally if let's say comes to solar installation, we always recommend that there's a concealed fixed profile. Yeah, so since goes to vegetation ready metal, just now what AR Michael mentioned also. So metal roof are actually vegetation ready metal roofing system. Actually super lightweight. So the green roof system actually designed specially for green roof on lightweight structure. So the system is also incorporate a lightweight pre-plant green roof composite mat system. So without any insulation or secondary substrate growing in the medium. So we also allow for the quick realization and extensive green roof. So this is also the lightweight truss. So the lightweight truss is actually giving a very fast efficiency installation on site, less labor, and of course easy fabrication and construction, zero waste on site. And also we use as a decking. So decking system used as a composite site for tall building, for high building, so to erect in extremely efficiency, fast, speed. So we also significant actually reduce the weight load and also reduce the concrete volume. So in the long, it's actually give you a lot of cost saving. So yet, back to my previous presentation again, that not all metal roofing are actually the same. So not all the metal cladding looks the same. Okay, so of course, back to my presentation earlier again, we have a classic form, rippled profiles. We have a strong modern square corrugated profile. And also we have this very bold, deeper bold and contemporary appearance. And also a bow ribs, this is the clip system where it's very high ribs. And also we have our conventional profile featuring the trapezoidal ribs. And also we have a shallow trapezoidal ribs with multi-ribs profile. And also we have our standing seam, a very, very low ribs and equal, it's exactly like a slim ribs. And actually feature the flat pants. Okay, so this is the profile that just now we mentioned that it can do wonders. It can go taper, it can go dome. And also we have our seam profile in very high ribs, high bow, and go with very, very low flat roof, like at 1 degree. And steel roof application is sustainability drive. So yet, back to steel again. Steel normally we don't stand alone because we still need a lot of insulation material to come up a system, like let's say for you to comply U value or either to comply STC. So we cannot run away from insulation material. So we have to partner a lot with our insulation material. So some play a very big role, some play a very minimum role. So it depends on what kind of requirement that you're looking at. So this is some of the example of the metal roof build-up system. So the outer cladding, we have this called double skin, which is two layer of metal decking. So we have our metal decking, we have our insulation wool, then also we have our foil, then we have a next layer of a metal decking. So schemes goes to the wall cladding. So this is the wall cladding. So some wall cladding, they actually have another build-up with drywall system, not only must be in metal deck. Yeah, so this is also comes to single skin and double skin. So of course, single skin, you have better, easier way to build up. But of course, comes to U value or comes to STC, is actually lesser efficiency compared with the double skin build up. So in a layman term, it's like the more U value that you ask for, the higher STC that you're looking for, the build up system will be more bulky. Yeah. So comes to STC. So it comes to sustainability, we cannot run away for U value and STC. So STC is a bit different from U value. So if let's say we refer U value to your health, your blood pressure, your cholesterol, the lower the better. But come to STC, it's actually referred to your face. The higher the better. Yeah. So the higher the STC is actually better. So just how we actually take this STC as a benchmark is like, if let's say we are talking about STC 30, means it's actually 30 decibel cut from the outer to the inner sound. Okay, so normally example, like let's say I want to build a building just next to a very high traffic environment. So let's say the traffic, the area, the highway is actually at 100 decibel. So we are talking about the safety level for decibel is actually 60. Okay, so means 100 to 60, we need a STC 40 build up. Yeah, so this is how STC works. Yeah, of course, when it comes to STC, the higher density, the material, it will help more on STC, sound transmission. Means like example like cement board. Cement board so helps a lot on STC, but it may not helps a lot on U value. Yeah, or something like a PE form. Okay, so wool may actually helps a lot to generate a good U value, but it's not help a lot in STC. Yeah, it can be do different way. So when it comes to STC, we need a very high density material to perform, to create this STC. Yeah, so this is one of the example in our Australia building. So this is actually a building that we have a STC of 51. Yeah, so this is a build out of STC 30. So you can see the airborne sound for the external is 70. So once you have a STC 30 build up, means the internal sound will be 40. Okay, so this is one of the example that the different builds are for STC 27 and STC 42. So you can see at STC 42 that we need more component like cement board, air gap, and a thicker wool to actually generate the more high density rock wool. So you can see the rock wool here is actually 64 kg. Compared with the STC 27, the single skin is actually at 48 kg. So as mentioned, STC needs higher density material. Yeah, so back to R value. I'm not go detail at this, but because Mr. Michael already have a very comprehensive to explain this R value just now. So yes, the R value is the higher the better. The better R value of that material is actually give you a better of U value. Okay, so this U value is like heat transmission, thermal protection, that how you cut the thermal external to your internal the internal temperature. So this is very important in U value calculation. So this is some of the example of U value calculation. It's actually 1 equal to total R value. So this is how the numbers. Yeah, so this is one of the example that if let's say it's single skin, so you look at this single skin, let's say I only use a 50 rod wool, then my R value is actually 1.609. Then so if let's say U value will be 0.62, so it actually doesn't meet the UBBL. So in order to meet the UBBL, I may need to change the component. So either I add in airspace or either I need to change the component to thicker the rod wool from 50 to 100 Yeah. So this is the one that, let's say, customer asks for STC. So with this build up, definitely we know that this is definitely 100% is going to meet U value. Because cement board is also giving you some numbers of R value. And you can look at this is actually 100 rod wool. So in roofing method deck, right, it's very simple as long as if you want to meet the very requirement, minimum requirement for UBBL 0.4, right, as long that you just apply 100 rod wool or 100 wool, then you will actually, you can meet 0.4. But of course, this system built up because that the client needs some STC as well. Okay, so that's another question. So let's say people also ask, hey, Wendy, I like this system. I want to use this system, but I want to change the sequence a bit. So I want to change the sequence. I don't like the aluminium foil under the cement board. I want to put the aluminium foil maybe under the rod wool. Then after that, metal deck. Is it workable? It's actually not workable. So just now where we also mentioned that in certain MS2567, aluminium composite, it doesn't have its own R value. So it's a refractive item, it's a aluminium barrier, so it needs some airspace for it to reflect the thermal. So that's why it needs airspace, only that the aluminium functional. And also because aluminium composite is the emissivity at 0.05, so only we can refer it to the RSI table and generate the airspace U value. So if let's say a cement board, then straight away I have a airspace in between the cement board and the rod wool. It doesn't give you any good U value because cement board is not emissivity 0.05 and below. It's very high. So if the cement board don't have emissivity, right, then it doesn't create any airspace benefit for you. Yeah. So this is a system built out on the sequence of how you're going to lay your panel or your accessory. It's actually very important as well. Okay, so this is some of the tables that we refer. We have table 15 to refer the reflective and non-reflective. And also we have our RSI table to calculate the airspace. And also we have our, this is the MS2095 is for the aluminium foil. Okay, so it shows that here aluminium foil, it don't have any R value by itself, but it is a thermal, it's a reflective barrier to give you the airspace reflective. Yeah, so seems back to previous again. So metal roofing are actually a solar ready roof. So there's some example of project that we actually, I mean, it's like comes to metal decking is very good because like the client may be not immediate to install solar panel. They may actually install the solar panel after 5 years or 10 years the use of the building. So solar panel can be installed anytime, as long as you feel it, even like after 5 years or after 10 years of your building. Okay, so and also the concealed fixed roof with minimum maintenance. So it's just a very easy installation, just to click on, easy maintenance. And of course, the use still in long span application. So we actually comes to metal deck. Why we like metal deck? Because like it provide a roll on-site service. So what this roll on-site service is like, they actually roll the metal deck according to your building length. So there's no overlap. So when we compare with, let's say I roll on site, I bring the whole entire machine, roll forming machine to the site, say at maybe 10,000 cost. But at the same time, I probably, if I don't have roll on site, I maybe need 20 trucks to carry my material to the site. So come to sustainability, actually roll on site are much more carbon footprint compared with transport. Let's say I do in manufacturing, I do in factory, then I delivered. Yeah, so instead of I just use one truck to send the machine to site, rather than I use 20 trucks to send the finished good on site. Yeah, so we can do the comparison. What is the most effective cost for you? And what is the most sustainability or carbon footprint way to manage your project? Yeah, so again, ground roof solution, we are ready on that. So still in sustainability and design case study, so we have some case study on how this still apply to sustainability. So this is one of the project in Australia, in Phillips Island. So this is a penguin, we call it penguin colonies. It's a penguin shelters. So we have a lot of challenge. We face a very huge challenge for this project is because you can see the landscape, the land, the area is actually all very uneven. And they want to build this building in very, very, very minimum carbon footprint. So we face a lot of challenge. First, what is the challenge is, the challenge is like, we have about 32,000. I think last year we have an update of 32,000 penguins stay here. Okay, going to have a lot of activities here. So when it comes to this installation, and comes to material selection, first, they want a very low carbon footprint material. Secondly, they want the material to be installed on site, but yet doesn't disturb the tourists, and doesn't disturb the activity, and also doesn't disturb the penguin. Yeah, so this is very challenging. Yeah, so then after that we have our proposal. Of course, steel is the choice, the only choice they have, because they can carry steel very easy. They carry piece by piece to the site and easy to manage. And of course, when it comes to steel installation or fabrication, there's no sound, no noise, no waste on site. So it actually doesn't disturb the penguin breeding time. So that's very important on material selection. Yeah, so of course, durable, pre-painted, and also because the challenge is like that area is actually the weather, the extreme weather. It can be very, very cold, and the people is like to work on site is also very challenges. Yeah, so then we have another project, School of Design and Environmental. So this project is actually they want to go for green. They have 1,200 pieces of PV panel going to install on the roof. Yeah, so this is the design. So a key features of the building which actually designed to be energy efficient. So they have 1,002 PV panels to actually harvest the solar energy on the roof. So this building concept is like they want to generate their own energy. At the same time, they also want to harvest their own rainwater goods. So they want this building exactly go GBI, go 100% green. So this is also the option that we give to them. Is like we're using our clip cloth bofas. And this is also just now what I think A.R. Michael mentioned is very important. It's like color is very important. So when it comes to steel selection, right, how we determine on color selection when go to your GBI building is based on SRI. So SRI is solar reflective index. So the higher the SRI, the better. So example, like let's say today you wear black, so you will absorb more heat. So when you absorb more heat means that you have a lower solar, the lower solar reflective. So means the lower the SRI, the higher the SRI, the better. So when it comes to green buildings, right, we would always recommend to select the color which have the SRI of 80 and above. Yeah, so that's normally go for white color. Yeah, so dark gray probably maybe 60. Darker maybe 40, 40 plus. Blue maybe like 60, 60 plus. Yeah, so color is very important. Okay, but yes, so we actually offer this client, then they actually select off-white. Yeah, so when it comes to GPI point, as long that you choose the correct SRI colors, right, it will actually give you an automatic 1 point. So we call it color point. Yeah, so this is another project in Mapletree, very close to our office. And this logistic hub is actually based in Shah Alam, the town city of Shah Alam. The logistic hub in Shah Alam. Yeah, so same goes to this building is also asking for solar panel. So the beauty of this building is actually they use 100% LED light. So the daylight harvesting, so at night then the LED light will actually function. So this Mapletree project is actually also requires solar panel, and we are the one who actually go up to the roof to do the assessment, and we are also the one who actually propose them the PV. Yeah, so this is the solution. So same goes to what I just now highlights, like when it comes to solar installation or solar PV, right? Let's say your client have an intention to go for solar. Clip lock is always the best profile for solar. Why? Because that you don't want to have any maintenance and you don't want to have any leaking happen after you install your solar. Yeah, because to rectify the problem after you have the solar panel is actually very difficult. Not say impossible, but it's just very difficult, and we actually incur a lot of costs. Okay, so this is the project. And yet we also have this MBPP sport complex in Penang. So this sports center, they have 10 badminton court, they have gym, they have swimming pool, they have everything about inside that. So this is under Majlis Bandaraya Penang. So they're also asking for green. So the beauty of this project is actually you see the building actually created using recycled steel framing structure. Yeah, so the steel itself, the beam itself is actually a recycled steel material as well. Yeah. So incorporate, then they actually use everything in steel. Same goes to the metal cladding. They also choose metal cladding. Yeah. So and also this building, both roof and the wall cladding actually contribute a lot to GBI points, and also it helps the MBPP Relau Sport Complex earning a GBI non-residential new construction sewer certification. Yeah. This is the last project reference. So this project is actually inspired by the bund. So they want to build the building something like that. So you can see on my right-hand side, this is the original build. This is the original idea they want to. It's actually using Croton steel. Then after that, they found out that this Croton steel have a very big challenge. First is the price is very expensive. Second is like this Croton steel is very, very hairy. So the most hairy material that you're going to use for your outer skin of your building, you have to increase your building load. So at the same time, it's like Croton steel also very expensive. You build the building also that you have to thicker the beam. The structural design also have to go thicker and thicker to take the load. So after that, we comes into a proposal. We say that, hey, why not like, let's think about steel, whether we can do it, what that you think of. Then he said, yes, why not we explore? Yes, then after that, we come out the solution that we actually propose steel in our in a seam profile. In a seam profile. Then also that we actually do color match to the original bund design colors. It's an orange color. Yeah. So then the architect adopt the idea. Then this is the final buildings that we built. And same, but yet to highlight this, this is not only, this is actually doesn't qualify any GBI, they don't go for any GBI, but the things is like, when it comes to sustainability, it's actually they save a lot of cost, sustainability, and because of the weight of material, the difference of Croton steel and the steel material is different. Okay, so today I'm end here. Thank you. So.
Okay, thank you both. So at this point, I'd like to ask both our speakers to please come on to the stage for the Q&A. Ms. Wendy and architect Michael. So of course now it's open up to the public. Who would like to get the first question posed to our speakers on the stage? Can we have there were a lot of questions just now. I remember seeing people were asking questions, so now's your time. Anybody, just raise your hand. Someone will pass you with the mic. I think there's one at the back there. There's one at the back, I think. Can you raise your hand, please? Yeah. Please introduce yourself and who the question is directed to.
Okay, good afternoon, everyone. My name is Wawa from University Tunku Abdul Rahman. I would like to ask my question to Architect Michael regarding the OTTV and window and wall ratio, and also the shading device. Yeah, it will reduce the windows ratio, right? And also we add longer horizontal shading device. Yeah, how it affects the natural lighting? Yeah, it's always become my question. Yeah, we reduce. Okay, obviously it will reduce the penetration of the natural lighting. It reduce the natural lighting penetration, so we need to increase the artificial lighting, right? And also it will increase the energy. Okay, based on your experience, yeah, do you have this kind of experience? Would you like to share with us? Thank you.
Hello. Okay, very good question. It's always the balance between heat and light and ventilation. The first thing that we do, we need to know what is the ratio of light penetration. Okay, normal 1:1. Normal rule of thumb, all rule of thumb, of course they have calculations, 1:1, which means that if your window is 10 feet, your light goes down 10 feet. As simple as that. That is on direct. Okay, in diffuse lighting, it goes 1:2, 6 meters down. So if your building is 6 meters down, diffuse light, if your depth is 6 meters down, 3 meter height, that is as much as you can. So if you stoner, for example, the room is living room, dining, living room, living, bedroom 1, bedroom 2. We know it's 10, we know it's only 3 meters. Ratio is 1:1. If I cantilever out my horizontal 1 meter, that will reduce to 2 meters. If the ratio of 1:1 is 2 meters, 1:2 is 4 meters. Enough lights, no issue. You can do simulation to confirm that, but rule of thumb, boleh. Okay, so you need to know the ratio. From there, you know what is the works. This ratio is through the last 15 years, 100 projects that our company has. It may be very different from the actual, slightly different from the actual other people project practical cases, but it's an average. So the first thing is the light ratio. The second is that, and of course we have projects that we introduce the shading device in between glass. That's called light shelf, where the bottom is actually, let's say the stoner, we didn't do that, 3 meter, and we need only 2.4, let's say, or 2.1. 2.1 still taller than all of us. Then they have shading device, that would put it 7 feet. With 7 feet, then you know is times 2, then it's 14 feet, then your light's still there, but the light show on top can actually bounce to the lights and actually go deeper. So there's actually 2 strategies to bring light to control with the deep tap and the right ratio. Thanks.
I hope that answers your question. Very thorough. Okay, walking encyclopedia here today.
No. Sharing experience
You
only.
know, you got your ang pao packets over here. Do you want to give any of the audience members who actually ask questions? Of course, how much is in the ang pao is a different story, lah.
Usually is cash rebate.
Okay, can we have the second question, please? Who would like to ask? The questions are also open to members on the mezzanine floor. Okay, not just obviously on this floor. So who would like to ask question number 2? Very thorough.
Usually Malaysian, very shy.
Very detailed. Okay, we have one question, the gentleman over there. Please introduce yourself and who the question is for.
Right. Hi, good morning. My name is Ari. I think I have 2 questions. First question is for Michael and second one is for Wendy. So Michael, the first question is regarding the vertical louvers, where you say that if we have different length, short and long, why does the long one is not calculated, taken into consideration? And then for Wendy, it's regarding the, because earlier you did say that all your roof types, standing seam or clip lock, they are ready for solar panels. However, I think towards the end of the presentation, your recommendation is actually to use clip lock system if you want to use solar panel, and could you explain that further? All right, thank you.
So who would like to go first? Okay. All right.
Yeah, so just now I say, yes, all the roof are actually solar ready. So even that if you use a pier facing metal deck profile, it's also okay for solar. But my recommendation is always like, because I want to go for very minimum maintenance, and I don't want to have any hassle to your client in after like 5 or 10 years. So let's say if you have a screws on top of your roof, there's no problem for you to go with solar panel. There's definitely no problem. But yeah, in long run, then if let's say one day with the thermal expansion, you don't know that whether the leaking, whether the screw condition, is it still there or not still there, or still in a good condition to hold the metal deck. So if one day, if let's say the screws start to corrode, and that's where the water going to penetrate, or where's the water start to leak. So if let's say the leaking was just happen right after the solar panel, then you have an issue. Because you cannot rectify the problem when you go up to the roof or all solar panel. You can't even spot where is the leaking part. Yeah, so how you're going to spot the leaking part? First, you have to remove all your solar panel. Then only you can feel or you can repair the leaking part. Then you have to put back the solar panel. Yeah, so this is something, the problem that we have to look in upfront, like after 20 years. Because wherever the building that we submit to the client, we are not just foresee 1 or 2 years' time. Yeah, we need long term. Yeah, thank you.
Actually, I was wondering about that myself. The weight of the panels are not a problem at all with the system that you have to employ on the roof.
Again?
The weight of the panels is no issue whatsoever. Basically, you just clip on directly only.
Yes.
Okay. I think that's pretty good knowledge, isn't it? I think most of us are already thinking about how to do that for some of our projects. I'm sure some of you are doing some designs relevant to metal roof. And I know some of you are thinking about it. That's why some of you are smiling, wondering whether it's possible or not. Okay, can we have a few more questions?
I haven't finished.
I'm sorry. Sorry.
Two questions.
I apologize.
Okay.
Can we have the second question?
I always prefer to stand. MS-1525 developed many years ago. So at that time, it's a static. MS-1525 is before GBI, many years ago. GBI developed, some of the clauses are actually extracted from there, including OTTV, including the SC. So it was, the horizontal fin was developed then. So the orientations and the fin. So the calculations are all static, step-by-step calculation. No simulation, nothing. So from that calculation that I show, it's actually based on the worst-case situation, which is the shorter one. But if you want to be one long one short, definitely the long one will have impact. Definitely, no question about it. But in the calculation, there's no. So you need to go to a simulation to do a OTTV to further reduce. Yeah. That's the truth, lah.
Okay. So let's proceed to the next. Okay, we have one more from the gentleman over here.
Hi, my name is Michael. I want to address a question to Michael. I'm very worried about the EMS. What kind of EMS that we are going to have? Because why? Because for whether we need to provide a system, we have a sensor, everything, so that it can automatically address something like give a vague idea about the EMS.
Oh, sure. Okay, I think like today's topic is we need to understand the concept. From a concept, then we know what need to do. EMS, what is the objective of having EMS? That's the main thing. EMS doesn't equal to sensor, okay? Because EMS, the objective is actually one. Okay. Two the first one everybody knows renew energy. But how to renew energy? By tracking, monitoring, and tracking. One, monitoring. Two, tracking. These are the two very important. Monitoring is just like, goes to water first. Everybody day-to-life problem. Where your water bill comes the next month, 1,000 or koyak, somewhere leaking. 1 month later only, because there is no monitoring. Monitoring is 1 month later. TNB bill, same. Every month, 1,000, okay, a few hundred for houses. So then the next month, 1,000. What happened? No monitoring. Okay, for this for houses. For a main building, EMS required is 4,000 square meter and above, which is equal to 40-something thousand. Medium-sized building. It's actually for real-time tracking. That system will track any abnormal, any maximum demand, whether it hits, because your design is based on maximum. Of course, when it hit, what happened, and what is the fluctuation, what's the pattern, they will actually monitor. And if suddenly shoot up, shoot down, they will alarm, and the alarm can be through the monitor, or it can now goes to the phone. Then you know something happened. Monitoring, okay? Monitor what? Energy efficient product, aircon, lighting. So they may be sensor, they may not be sensor. Outside our building, PAM center, outside, doesn't need sensor. Most of the project here using is at daytime. At night, hardly people. You sensor for what? Mine saja. So sensor, if it helps to track energy, yes, do it. If it doesn't, it's objective based, no need. So aircon system, the entire system, lighting, travel, mood travelator, escalator, and all that stuff you need to track. Pumps. So these are the important things that you need to track to see what is the usage monitor. The second one is adjustment. Okay, so first thing is monitor, then control. Control adjustment is very important. Where you know that's the issue, you know exactly where to stop. The pipe leaking, we know exactly where part, for example, and where to switch off sub-metering. So that's why in GBI they have sub-metering, and they know where to. Sub-metering is just not to have sub-meters for the sake of sub-meter. It's where do I need to cut it, where do I need to on it. So it's control. So it's monitor and control. What is the cost of BMS? If you look at EMS energy, not BMS, it's cheaper because it's only track energy. If it's a B, it tracks a lot more things, including your water. E track photovoltaic as well. Do you know that the photovoltaic, if you guys at home install, the figures at your apps and the TMB bill doesn't tally one, you know? Why doesn't tally? There's a loss. Who track this loss? The EMS can. Okay. Otherwise, you need to do calculation. Confirm. You go back and check your PV that your supplier give you. There's always the apps and a TMB. Never. I've tried it many times. All project tak sama. Very very close, but tak sama. Okay. So you need to track. A DMS can help you to track. Okay. Thank you.
Okay, thanks. Let's have maybe one or two more questions before we wrap up for the day, because we're pretty much on time. So who would like to ask the following question? Okay, we've got another one over there. This will be the second last question, yeah?
Hi, hello, good afternoon. I'm Jonathan from CLO Architect. I have two questions for AR Michael. So the first one is, currently I have a project, high-rise residential buildings, tower. So at the top roof there, RC flat roof, original specification was using the insulation on top of the RC flat roof. Then throughout, client decided to omit it. So in terms of to achieve this U value, can I propose like use the insulation, put underneath of the RC flat roof, but on top of the ceiling, by using like thermal air bubble insulations? Okay, so this is the first question. Second question, okay, is this requirement need to comply the entire those RC flat roof below it? Like for example, because my project is residential, so can I just put the insulation in the units area? So for the common area, can I avoid it? So this is the second question. Right, thank you.
Okay, first question. The thermal mesh rigid insulation put on top of the RC, it meant to reduce the heat thermal conduction so that it stops the heat. Then the thermal construction stops there, so your slab will be less hot. Therefore, by radiation to reach you lesser. The moment you do that, your slab all heated up already. 40 something, no joke, 40 something degree, can heat to 45 also can hit, 40 something. Then it only goes down to your installation, but every 8 meters or every shear wall, every 3 meters, there will be thermal bridging. So the heat actually come to down thermal bridging at 40 something. If I put the insulation on top, the slab itself can heat to 30. So there's a 10 degree difference from the starting point where the roof ends, and it comes down. Okay, and if you do that, the heat definitely you can feel compared, because it's 10 degree difference. The only way to do that is to do a simulations, energy simulation. If you do a calculation using the MS-1525 using the layers format, it will pass, sure pass, but in reality it will definitely fail. So you need to wrap the insulation below to reduce the heat all the way to the thermal bridging level until 26 degree set by GBI. Once it hit 26, it's more or less equilibrium. Then you can stop the insulations. From there, you're okay. From our experience, you need 600 down. So you need a ceiling of 600 from experience. So you need to do a simulation to do that. First question. Second question, lupa already. Wala. Okay, can. UPBL says that all installation area to habitable space. Okay, some people start to argue, hey, my unit, the toilet not habitable. No, it's the entire unit. Cannot pick and play. So it's entire unit. The corridor that links to the two units, let's say is a lot of design. If you have two double loaded, you have air well either side, and then on top, there one's metal on top could be just RC, and then ring can actually go through. So it's all natural ventilation. That can be omitted. Okay, that corridor can be omitted because it separated the two wings. Even though the thermal bridging that heat up the slab, that then pile to go into the slab is actually much lesser. So that part can. But the moment you're on top, you have gym and all habitable space, all need to do. Only the MAE room are exempted. Anyway, the MAE double slab. Let's say you have lift motor room, RC. The unit below, no need insulation. Sure, gao. Okay? Good night.
Okay, so one last question, and then we're going to wrap it up. And then, of course, if you want to ask anything else, perhaps you can approach both our speakers later. Who would like to ask the final question for the day? Those three ladies up there taking selfie, tanya. Okay, unless there's anything else, I guess. Maybe the two shall, they just approach you later. Okay, yeah, I guess they'll be around. I'm sure there's a bit of time. Please give them a round of applause. Okay, thank you so much. That was really, really informative.